Okay, this is my Lab 5 extra credit problem. Basically, we'll just be solving for the moment of inertia. This is a very similar problem from homework number 4. Basically, you just got 3 separate shapes here. I went ahead and labeled them shape number 1, 2, and 3 for our reference. Got your dimensions there. So let's go ahead and start by finding our centroid for the overall built up shape. So that's basically, you'll find your x bar and your y bar. So we'll start with our shape. So we got shape number 1, shape number 2, and shape number 3. Area will always be in inches squared. So for area 1, you got 6 inches times 2 inches. That'll give you 12 inches squared. For area 2, you got 2 inches times 6 inches. Also 12 inches squared. And for shape number 3, you got a total of 3, 5, 7, 9, 12 times 2 inches is 24 inches squared. Move on to y bar, I. It's a y. So the center of shape number 1 to the bottom is 2 inches, plus 6 inches is 8 inches, plus half of 2 inches is 9 inches. Shape number 2 is 2, plus half of 6 is 3, so 2 plus 3 is 5 inches. And for shape number 2, it's just half of 2 inches, which is 1 inch. One thing I forgot to do a little sum row here. Let's go ahead and sum our areas. 12 plus 12 is 24, plus 24 is 48 inches squared. Don't worry about summing yi. Go ahead and do ay. So all this is just your area times your y bar. So you take 12 times 9 and you get 108 inches cubed. 12 times 5, 60 inches cubed, and 24 times 1 is just 24 inches cubed. Go ahead and total these up. 108 plus 60 plus 24 is 192 inches cubed. X bar I. This is the distance from the center of each shape to the left-hand side. So basically you got 12 inches here all the way across. So the center will be the same for all 3 shapes. It'll just be half of the 12 inches. And that'll give you 6 inches for x bar I for all 3 shapes here. Once again, you do not need to sum x bar I. Go ahead and do ax bar. All this is your area times your x. 12 times 6 is 72 inches cubed. 12 times 6, once again, 72 inches cubed. 24 times 6, 144 inches cubed. Sum that up, you get 288 inches cubed. Okay. So that's all the table we need to find our x bar and y bar. Go ahead and find our y bar. That's just your sum of your ay bars over your sum of your areas. So you got ay bar 192, a 48, squared, cubed. Inches cubed over inches squared gives you inches. That's how you can check your units. And that gives you a total of y bar equaling 4 inches. We'll do x bar. Sum of the ax bars over the sum of the a's. 288 over, once again, 48 inches squared. X bar is 6 inches. All right, so now we have our centroid. All right, we know our centroid is 6 inches over. So if this is your origin here, you go 6 inches over and 4 inches up. And your centroid will be somewhere right in there. Now, the next part is to create another table to solve for moment of inertia. So part 2 is find moment of inertia, aka Ix equals bh cubed over 12. I'm sorry, let me rewrite that. Ix is the sum of the inertias plus a dy squared. But, yes, actually that is right. Yep. So, we need to do our shapes. Alright. So we got shape 1, shape 2, and shape 3. Move that up. Try not to spill everything. Alright. So, moment of inertia for each shape, once again, is bh cubed over 12. So for shape number 1, you got 6 inches times the height of 2 inches cubed over 12. Punch that in a calculator, you get 4 inches to the 4th. For shape number 2, you have a base of 2 inches times the height of 6 inches cubed over 12. Put that in the calculator, 36 inches to the 4th. And for shape number 3, base of 12 inches, height of 2 inches cubed over 12. That gives you an inertia of 8 inches to the 4th. Now let's go ahead and sum these. So you got 4 inches, 36 inches, 8 inches to the 4th. That'll give you 48 inches to the 4th. Now we'll do dy. So all dy is from the difference between the shape's centroid and the centroid for the overall shape. So the shape centroid, also known as, we could also look at it as being the y bar I, so it would be 9 inches here. So you got 9 inches for shape 1, subtracted by the centroid of the overall shape. So you got 9 inches minus the centroid of the overall shape, which we found here to be 4 inches. And that'll give you a dy of 5 inches for shape number 1. Likewise for number 2, the centroid of the shape is 5 inches minus the centroid of the overall shape is 4 inches. That'll be a 1 inch difference. And for shape number 3, 1 inch minus 4 inch equals, once again, this is the absolute value, so the difference is just going to be a positive 3 inches. Don't worry about summing that. Go ahead and make an ADY squared column. Don't forget the squared, I do that a lot. I guess A we'll get from this column up here. So for shape 1, it's 12 inches squared times dy, which we found here to be 5 inches squared, and that will give you 300 inches to the 4th. Area for shape 2 is 12 inches squared times dy, which is 1 inch squared, and that gives you 12 inches to the 4th. Area for shape number 3 is 24 inches squared. Multiply that by the dy, which is 3 inches. Square that, put that in the calculator, 216 inches to the 4th. Now this column will also want to add the sum. So you got 300, 12, 216. Add that up, 528 inches to the 4th. So now you got your sum of your Ix's, sum of your ADY squareds. Throw this back in the equation. 48 8 inches to the fourth plus 528. That gives you a total moment of inertia for the overall shape of 576 inches to the fourth. And that is how you solve for moment of inertia for a built-up object. Thank you.